For an HVAC duct and fittings fabricator, gaining efficiency in the fittings fabrication area of your shop is critical to improving profitability. In this series of videos, we'll examine some strategies, from automation to shop floor layout to specific machines that can help you maximize the productivity and profitability of your fittings fabrication operation. In a square fittings fabrication operation, gaining efficiency is not just about purchasing the latest automated machinery. In order to capitalize on your machine investment and increase your profitability through productivity, your shop floor layout is critical for success. In this video, we'll take a look at one setup designed to maximize efficiency. The backbone of your square duct fittings operation includes the following. 1. Cutting operation. 2. Operation for smaller fittings, utilizing lighter gauge materials for lighter pressures. 3. Operation for larger fittings, utilizing heavier gauge materials for higher pressures. 4. Corner insertion. Beading and insulation are also important operations, but since they are not required in all jobs, they can be thought of as secondary from the standpoint of the flow of material. The key is to align these operations in an uninterrupted, logical workflow that minimizes the distance that materials will travel and the accumulation of work-in-progress inventory while allowing for sufficient room for each process. Of course, this will be different in every shop, given the square footage of the facility, the available machinery, and the volume of product that is manufactured. At this facility, the fittings fabrication area starts with the plasma. They're using a Lockformer Vulcan Plus sheet metal plasma cutting system, featuring a 20-foot table which provides a couple of distinct advantages. As shown in this operation, the plasma can be sheet-fed. In this case, they can load two 10-foot blanks, flat, as seen, or beaded, which gives the operator the ability to pick up cut pieces on the front of the table while the plasma continues to cut on the backside of the table, so it's always in production. This machine can also be coil-fed by an Iowa Precision coil feed, with an optional beading unit to optimize how much can be cut from a full 240-inch length of material, while still allowing the operator to pick up cut pieces on the front while the plasma continues to cut on the back. From there, this shop has added a secondary beading operation for those jobs where the duct is exposed and the beads have to line up. The beading machine is installed in line with the subsequent operations, but offset enough so as not to disrupt the flow of material when beading is not required. At this point, the operation splits into two parallel paths, depending on the type of job. Path 1 for smaller projects calling for smaller fittings, lighter gauge materials, and lighter pressures includes a cleat former to make the S-cleats and drive cleats. In this case, a Lockformer Triplex cleat former. 2. A Snap-Lock roll former for the male and female Snap-Lock seams. In this case, a Lockformer Button Punch Snap-Lock seam roll former. Path 2 for larger projects, including larger fitting production, heavier gauge materials, and higher pressures includes a 16-gauge Pittsburgh roll former. In this case, a Lockformer Pittsburgh roll former. 2. A transverse duct connector (TDC) or transverse duct flange (TDF) roll former. In this case, a Lockformer transverse duct connector (TDC) roll former. This last machine can be a game changer for your operation because it eliminates the manual process of installing slip-on flange connectors. With transverse duct connector (TDC) roll formers from Lockformer and transverse duct flange (TDF) roll formers from Engel, you can roll form your own sealable flanges on transverse duct joints during the fabrication process, eliminating the added cost of slip-on flange. There is no functional criteria difference between the TDC and TDF flange, and both meet the SMACNA T25A and T25B requirements. The only difference between the two profiles is the hem on the flange. TDC hem is on the outside, while the TDF hem is on the inside. From here, many components will head straight to the assembly operation. But since many jobs will require installation, a secondary operation is needed. For this operation, there are two machines that can dramatically improve your productivity. First is the water jet for cutting the insulation. The advantage of a machine like the Lockformer Vulcan 1600 fiberglass and insulation foam water jet cutting system is its ability to perform cutting with zero scrap factor on insulation up to 4 inches thick at 1200 inches a minute. That's approximately 1/10 the time it takes to cut them by hand. This also reduces material waste and provides a very clean cut, so unlike a plasma, there is no scrap between cuts. This zero scrap factor can reduce your scrap by up to 75%. The second machine is the pin spotter, used to pin the adhered insulation with mechanical fasteners to the duct form. One thing to note in this operation is the open space needed to manually rotate the forms to get the fasteners in place and be free of hazards or incoming materials. Whether you're cutting insulation manually or with a water jet machine, similar to the beading operation, you want the insulation cutting and installation operation to be in line with the preceding steps, but offset enough as not to disrupt the flow of material when insulation is not required. From here, it's over to the assembly operation. This area is set up to provide an ergonomic workspace with high tables that provide the worker with a proper range of motion to not only prevent wear and fatigue, but also to keep the process moving without physical or procedural setbacks. As with many operations in this facility, corner insertion is done by hand. This manual process is not only slow and labor-intensive, but also inefficient and imprecise. Corner insertion can bottleneck the entire fittings operation, negating any productivity gains that were made upstream in the process. This is where the Iowa Precision Cornermatic Plus corner insertion machine can speed up the process while ensuring a factory seal and eliminating the physically demanding process of manually hammering in corners. As you continue to look for ways to maximize the productivity and profitability of your entire operation, taking a hard look at improving your fittings fabrication area is a critical step. Of course, every situation and shop is unique, and there are many factors that impact success, from your available square footage to your existing layout, from your current automation machinery to your budget or need for new equipment, and, of course, your goals for improvement. That's why Mestech Machinery is here to help you make these evaluations. So when you're ready, please don't hesitate to reach out for a no-obligation one-on-one consultation with a Mestech Machinery technical advisor. We'd love to get to know you and your operation, get a good understanding of what you're looking to do, and see how we can help you achieve your objectives.